I'll introduce myself first. I am Jean-Luc Stevens. I am a senior software developer at Anaconda. So this talk is about seeing the needles and the haystack, and I'll tell you what that means in a second. Single data point selection for billion-point datasets. Now, the whole track here is about getting insights from big data. And if you want to get insight to something, a good way to do that is to visualize it. If you just look at all your raw numbers of your gigabyte datasets, you probably won't really get much out of it. So when it comes to visualizing these large data sets, you come up with quite a few different challenges. You can try to visualize big data, and you do that as one task, and then often you have to switch to smaller data sets as a separate task. And this is kind of an annoyance when working with large data sets. So as everyone here probably knows, data is cheap. It's getting larger year by year. We're getting gigabytes, terabytes, it just keeps growing. And we still need to see and understand our data and gain insight into it. So gaining insight into data is getting more difficult because you have more data to look at, and all sorts of things inside your data might not be quite visible immediately. There's a lot of places to hide different patterns and different things that you might be interested in. So some of the problems are many plotting tools that we have nowadays do not work very well with big data. Many things work in the browser nowadays, but as soon as you get to 100,000 points, things start to struggle, and then if you have gigabytes, you're probably going to have trouble putting that into a browser tab. Another specific problem about visualization is something called overplotting. I'll show you an example in a second, and basically what it means is that if you've got too much data, you have a high data density, and how do you visualize that high data density? Every single pixel of your screen is going to correspond to huge numbers of data points, which causes problems in terms of actually interpreting that data. And that's the key throughout the whole talk. You need to be able to interpret your data from all levels, from the zoomed out level where you can see everything, down to an individual data point. And another thing which is about visualization specifically is about the dynamic range of the data, which means when you have huge amounts of data points, often they cluster in specific places in your space, in your high-dimensional space, and then lots of places are sparse, and there's not much there. And then there's these points which are hotspots, which have all the data in them, and you have this huge dynamic range that you want to plot. So since 2016, we've had a project called Datashader. How many people have heard of Datashader? I'm just curious. OK, not so many. Which is a project which is actually a rasterizer, which is designed for large data sets. So if you're interested in Datashader, go to datashader.org, and you'll see some of the things we have. So for example, this is the entire US census. Now, the US census is, 330 million people, with lots of data for each person. There's a lot of data here. And you get one image, and you can actually see all the cities in the United States, and so on and so forth. Furthermore, you can zoom in, and you can use Datashader to do categorical plots. So you have ethnicity data in the census. So each color is a different ethnicity, and here we can see Manhattan, New York City. And you can do all sorts of pretty things with Datashader. So you notice that these are static plots, so that's an important point. So they're very pretty, but you get something which you can't really explore. You can just see the whole United States. What if you want to look at one city, So it rasterizes everything. It turns everything into a 2D histogram, which is the image on your screen. You have a huge data range. For example, think about how dense New York City is compared to, I don't know, rural Ohio or something. You'll see there's a huge range of population densities to think about. And if you use a linear color map, you wouldn't see anything interesting here. Not really. So what we do with Datashader is something called histogram equalization. Essentially, it's just a trick which comes from, I think, photography or just image processing, whereby you use your color map very efficiently to cover the distribution of the data that you actually have. This is why we have a nonlinear color map here, but you can really clearly see all the structure spatially across the United States here. So this is pretty, it's nice, but it's a static image. It's just a PNG, and that's what Datashader was in 2016. So this is great, but yeah, we want to start exploring data. So let's take a data set. So I've got something here, which is a herring gull data set. So these are birds. This is from Belgium, from the coast of Belgium, where we have about 2.42 million data points. Each one is a GPS coordinate of a gull. And there's some of the data I'll show you. So here's the data frame. Here's the head of the data frame. Longitude, latitude, the temperature. So they have sensors on these little things that they have on the gull. The heading, so the direction that the gull is heading. The height above means sea level, the easting and the northing. So easting and northing is just a different way of expressing longitude and latitude. You may not be familiar with it, but OK. So here's what it looks like with Datashader. This is, again, what it would look like in 2016 if you used the Datashader API. Okay, so you see there's structure here. You can see that there's distributions, that there's sort of pathways where the gulls fly, and sometimes they go along these routes, and they seem to be concentrated around here, but there's no context. You can't interact with it. You can't zoom. You can't do much with this. This is just an RGB image. It's so it's just a typical PNG image. So what can we do with this program starting in 2016? Well, you can view the whole data set. Datashader scales to gigabytes. As I said, the census is huge. Really large data sets will work, and you can use them in the browser in the notebook. There's no overplotting, and that's the point I was making about this histogram equalization. You can actually see the structure of the data, and I'll show you what overplotting actually looks like in a second. And it's using the full dynamic range, which is the same kind of thing. It's about using this dynamic range. And also the overplotting thing is the fact that each pixel is a bin, and you're counting the number of samples in that bin instead of drawing like a circle for each point, which you might do with a more classic plotting program. So let's do some interactive plotting. This is using a project called hvPlot, which you can see here on hvplot.holoViews.org. If you visit it and learn how to plot with this, it gives you an interactive API, just like dot-plot with pandas data frames, but it's interactive. And what I'm going to do is I'm going to downsample this. So we had 2 million odd points, which is too much for the browser. Let's make it 12,000 or so samples. Now, if we run this, we see what it looks like if you have a large for the browser data set, but not really a large data set. And you can see that you've got a lot of trouble. You have a solid blue here. You can't see what's going on, right? What you can do, of course, is zoom in. You can do a pan zoom. You can get closer. And then you can start hovering on these points. You can pan around. You have all this interactivity. You can actually start diving into the data from this zoomed out view all the way down to an individual point. But it's not the whole data. It's a subset of the data. You've missed, there's like 95% of the data is not here, or even more, actually. Is that right? Anyway. So what we've gained here is things like panning, zooming, using a tile server. So you have a background now. You can actually see the map, the actual coastline of Belgium instead of just this white background. And you get inspection, where you can hover on this and see the data of each single row in this data frame. So that's great, but again, it's not the whole data. You're missing out all this context. OK, so what we want to do now is start to improve on this situation, start taking these two worlds, the big data world, which you can do with Datashader visualization, and then the smaller world, we've got interactivity with, here it's Bokeh visualization using hvPlot. So what we have is in 2018, hvPlot added an ability to start interacting with large data sets. So here's the same thing, and you can see, you can recognize that from here, right? It's the same structure overlaid on this map. But now I can start to zoom in. And as I zoom in, it all adapts so I can still see my data. I can still see the hotspots. I can still zoom all the way in until I can see individual points, where each single point is a GPS coordinate of a gull at that time. So this is really nice. This is really, really great. You can start to actually see the structure and zoom in. So you've got the context, but what you've lost are the things I talked about earlier. You can't do that inspection thing, for example. That's gone. So you've gained some things, you've lost other things still, even with this newer API from hvPlot. OK, so yes, it's the whole data set. No, there's no overplotting. I mean, you can see the structure much nicer than you could with this plot, especially when you zoomed out. You can't tell what it is. You're using the full dynamic range because it's using these RGB images from Datashader, which are using this histogram equalization method. But you can pan, as you saw me panning around, and you can zoom, and you have a tile server. But what you don't have is a color bar, and you don't have the ability to inspect the points. OK. So the reason this is happening partially is because you're using this nonlinear color map, which is a very unusual thing for most plotting programs, which is why it's actually an RGB image, because you have to turn it into colored pixels and then push it to the browser and then display it. Because client-side, you can't actually use that information with a sort of linear color map like you might normally do. So what we really want to do is push the actual aggregates, which is the actual counts of how many samples are in each single pixel to the browser, and then color map it on the browser. This is a special feature which we've been working on and adding. So this is what happens when you use this normally. It's called rasterize. It's pushing the sort of counts to the browser. And you can see this if I zoom in. You can see, for example, how many, you can see, for example, there's like 357 samples from seagulls in that pixel that I'm hovering over. But that's not the actual data that I started with. This is just an aggregate, it's like a histogram, it's a count. And also you've noticed the color map's gone strange, and that's because I don't have this histogram equalization. I'm just using a log color map. If I use linear, it's going to be worse. I'll quickly just switch it to linear. Useless, right? All the seagulls are basically in this tiny point here, and you can't see anything. With linear, you can sort of see a little bit with log, but it's nowhere near as good as what we had a little bit earlier, right? Okay, so yes, using this way of using Datashader, you gain a little bit. You get some sort of inspection, but it's not really what we want. You've got a color bar now. As you can see, it's a log color bar, which I said was missing earlier. But you don't have the full dynamic range because we don't have this histogram equalization. Okay, so we're getting closer. And this is newer stuff. This is from about a year ago, so I'm still considering that fairly new, since Bokeh 2.2. Bokeh has added the support for histogram equalization. So what this means is we can now do this. And we now have this color bar, which you can see is not, it's kind of a strange color bar if you look closely, right? And you'll see it's even stranger when I start zooming in. You can see it's dynamically updating. It's kind of an odd color bar to interpret if you just look at the color bar. But if you look at the image, you can see it's very clearly showing you the structure of the data, right? I can keep zooming in. I can do box zooms. I can get all the way in. And now I have my full dynamic range, my full ability to zoom in down to an individual point. We're getting really, really close to being able to treat large data and small data in the same way in the context of a visualization. Okay, so here's the little table again, whole data set, no overplotting, full dynamic range, panning, zooming, tiles, color bar, but no inspection. So we're still missing one last thing that we want if we want to go all the way from our gigabytes down to one single row on our data frame. And that's the inspection tool. So before I show you how that's going to be done, I will mention that since 2021, there's actually matplotlib support to some degree, not everything supported in the same way with hvPlot or Datashader. But you can actually start using this tool, which is part of Datashader, to actually use matplotlib-based histogram equalization, panning, zooming. You have those features, at least, with this new feature in matplotlib and Datashader. I just wanted to throw some matplotlib in there, not just show you Bokeh. Okay, so we have almost everything we want. And as I said, we want to be able to inspect individual points in our gigabytes of data. So what we have is a way to look at this data, but we want to be able to think about it in a way that we can actually hover on a single point and actually see what's in that data point. So here I'm going to switch APIs. Before I was using hvPlot, which is based on HoloViews, and it's a nice, easy API. You just use .plot and so on. But because it's based on HoloViews, we can actually use HoloViews directly to use some of these newer features or some of these more advanced features. And this is a new thing. Again, it's about a year old, where what we can do is using a different API, we can get ourselves the same kind of little tile server slice of Belgium and the coast. And then using HoloViews, we can now use histogram equalization. So this is kind of exactly what we just saw. I'm not showing anything new here. It behaves the same way. It's just using a different API. So it's the same thing, effectively, as what you just saw. But using HoloViews, we can now take the last step, right? With this operation, which is called inspect, we can now overlay it. And you'll see what that means. In such a way, we can get our hover back. So now you see a little circle, and you can see the values. And I can see my whole data set where I don't know anything about this data, just find out where these gulls are on the coast, the whole data. And now I can start zooming in. I can do box zooms. I can do scroll zooms. I can pan around. I can really interact. And now I can actually go all the way down. And you can see these are like piers along the coast, right? You can actually see the individual piers and where these gulls have been. You can zoom in. And now you can take a single point out of all your data and say, now I know exactly the temperature. It was 30 Celsius on that day, on that time, at that point in time where that data point was taken and measured and recorded. So this is the needle in the haystack. right? There's the haystack, and what I just showed you was the needle. Okay, so now we actually filled out our entire table of features we would like to be able to interact with big data and small data in the same way, and use the same kind of tools for understanding our data, regardless of the size, right? Same kind of insights you can gain both levels. You just zoom out if you want to see everything, zoom in if you want to see something specific. Okay, so I won't go into this in detail, but part of what we do at Anaconda as part of the HoloViews group, which you can visit on holoviz.org, which is using a lot of the tools I kind of mentioned, at least hvPlot, HoloViews, and Datashader. Params in the background, you don't need to think too much about it, but it's there. Is create a dashboard. You don't actually need to look at the code too much. You can see it's like a couple of lines of code. And when you do this, you can actually serve it as a dashboard. It's using Bokeh server, and it's using all the features we just talked about. And hopefully, I might need to restart. Let's see. I might need to restart this. No. So back, and everything I just did in the notebook is now a dashboard which you could deploy, put it on a URL you can share with your colleagues, and they can also gain the same sort of insights that you get with your large data sets all the way down to individual points. And the thing that's really powerful about this is you will see things in your data that you never knew were there. You will have missed things with other tools, whereas if you use this kind of approach, you will see patterns and things. You'll say, what's that? And you'll be able to zoom in and find out what it is. And I might be able to give you a quick example of that in a second. Okay, so that's the dashboard. There's more to this than what I've shown you. This is kind of the overview of all the different things you can do. You can inspect, you can use histogram equalization, but we're doing other things too. For example, we're working right now on curves and time series, where Datashader can actually do time series, and what we have is like lots of, I don't know, could be neuroscience, where you've got voltages from neurons that you're measuring, or stock graphs. It could be all sorts of different things that are time series, and then you can basically use the same kind of thing of selecting individual points or individual traces, as it is in this case, out the whole thing. So this is a work in progress. It's not available yet, but we're working on it. And we want to also try and make this kind of ability available at the hvPlot level. So you can just do something like inspect equals true in the call, and then it'll be available with a very easy API. You won't need to use HoloViews directly. So I want to show you some really cool demos in the last few minutes I have, which are one showing another feature, which is polygon rendering. So let me see if, okay, so let me open this. Okay, let's try this. I had to shut down a thing earlier. Okay, so this is polygons, and the difference, of course, is points versus polygons. I need to restart, kernel error. If it doesn't work, I'll switch to the next thing, which is also even better, in fact. Okay, so this is polygons. So this is New York City again, except now we have the shape of every building in New York City. So the outline, not the floor plan, but maybe the contour of the outside of the building. So this takes a few seconds to run, and what you'll see is we're going to get another plot with Datashader. Okay, that might be a bit slow. No, there we go, it's sped up. Okay. This is a kind of a pre-processing step, which helps optimize things further. But it's only done once, so once you've done it, everything is quite quick. And now it should be putting up this plot, which is what I want to show you, where you can do the same thing, hover on individual buildings in New York City and see what they are. It might take a second to appear. There we go. Okay, so if I zoom in, I'm somewhere, I don't know, I guess it's Brooklyn somewhere. I zoom in, Datashader is doing all the polygon. It's actually normally faster than this. This is a remote instance. It'll show up the polygons, and then you'll be able to see the hover. Give it 2 seconds. Come on. Okay, I have it locally, but I'm not going to try it. Oh, it's coming up. Okay, I'll come back to it and show you at the end. Another really, really cool one. Oh, there we go. I'm just about to switch away. Now we have these different colored buildings. These are different categories of building, like houses of worship, schools, churches, that kind of thing. And now you can hover on one and see what the name of the building is, what kind of building it is. Okay, and the last thing I want to show you is the really big data. So this is called ship traffic. This is called AIS, and it's collected by the Coast Guard in the US of all the, something like the seagulls, GPS pings of ships that are floating around the US. First, I'll show you the static images, and they're very pretty. These are, I think there's 200 million, yes, 200 million data points here, and there's a lot of data, lots of columns as well, so it's actually more than that. You can see all these different stripes. You can zoom into Vancouver. You can zoom into New York and see the patterns of ship lanes in New York. Really cool stuff in the Gulf Coast, where you have lots of oil drilling, I guess. Fishing boats, which do these little circles, which you can spot. And yeah, there's lots of really pretty pictures here. And of course, you can then do categorical, so you can actually classify it by the different types of ship, different colors for each different type of ship, fishing ships, oil tankers, and so on and so forth. Mississippi Delta. And I think there's a color key. There's lots of these pretty pictures. Here we go. So here we go. Cargo, fishing ships, passenger ships, towing ships, and so on. And finally, I might need to restart. Fine, I'll try my luck with the deployment. I have a live version of this that I hope I can pull up in time. So meanwhile, while that's coming up, any questions so far? Q&A in a second, yeah, sure. Okay, so in that case, I will actually check if there's anything more to say, and then I'll switch to it. Okay, so everything you've seen is actually downloadable from this link. Anaconda.org PyViz project. So this is something called an Anaconda project, which captures all my dependencies on Datashader, hvPlot, everything into a single reproducible unit. And it's called Needles in the Haystack. And from that, you can actually run the same thing that I've just shown you. Wait for that to come up. There we go. So this is those 200 million data points. It's, again, zoomed in a bit. And what we see, again, are the same categories of fishing ships with the Datashader plot right here. And what I've got is, by default, this ship right here. This is called the polar resolution. And you can have a picture, because you can actually hook up callbacks and things, which let you, so for example, hit a web API, get the picture of the ship based on the name, or actually the unique vessel identifier, which I think is the MMSI, if I remember correctly. And then you have pictures of the ships in this pixel that I've clicked. So here we've got these two ships, and if I click somewhere else, I should be able to pick up another ship. It takes a second. There we go, another ship. It doesn't seem to have a name, this ship. And that does happen in this data set. And then, of course, I can zoom in and keep doing this thing, picking individual GPS transponder pings out of 200 million of these pings, and then find out exactly what I'm looking for. Again, it's the idea of this needle in the haystack. Okay, and I think that's it. Yeah.
Thank you very much. We will start with the Q&A session right now. So the first question is, what are some data format optimizations you can do to feed data to hvPlot efficiently?
Yes. So if you start with something like a CSV, you have to pass the CSV. It's not the best format. The thing we generally try to use is Parquet. We find the Parquet format to be quite efficient. You can start using things like Dask if you have really large data sets, and Parquet, and so on and so forth. There's also a project called Spatial Pandas, and I think then there's going to be a new project that's migrating to GeoPandas? Yeah. Whereby we have optimized formats which are actually spatially indexed, which means if you're doing a map, everything's got spatial locality, and you can do some clever tricks to essentially have fast indexing into a large data set by using the fact that it's you're looking at a small portion of the Earth, and you can just sort of cull a huge amount of the data sets just by the indices in the spatial index. So we have these extra things you have to do to optimize the data to make this work really, really well. But it does work even if you don't have optimized data for fairly large data sets. But if you really, really want to push it, there are more tricks you can always add to get even more performance out of it.
Okay, thank you. Like, the next question is, what is the biggest data set size the HoloViews toolkit can render?
Oof, good question. I think the census might be one of the largest that I think we've ever done. I don't actually, I'm sorry, I don't have to hand the size of the census data set. It's big. It's really, really big. And I would say that in theory, there's no real limit if you have a cluster and you have Dask and you can distribute your workload. You can do it on any size. As long as you have the RAM across enough machines and you're using Dask, the sky's the limit. There's no limit. If you mean interactive usage on a single machine, then you're going to be limited by the amount of RAM on your laptop, essentially. So, yeah.
Okay, thank you. The next question is subsampling done in the back? Oh, wait, stop voting. It's subsampling done in the background when wider area is selected, and the actual loading is done when zooming.
So for the way Datashader works, it's actually interesting that by default, it actually does a full pass of the whole data set every time you render anything. These optimizations, it uses number behind the scenes, which really can speed things up hugely. And there are these extra optimizations we could add, but we've not really found need for them. We can actually do a full pass of the whole data set, that even if you're zoomed in, we actually, for Datashader, we're rendering the whole thing, the whole data set, we're doing a full pass where every single sample adds to each pixel. And that's the thing I didn't actually mention, which is this is really scientifically accurate on top of everything. Every single person in the United States is contributing some tiny amount to this plot, right? Every single sample counts because it gets binned into a histogram, and that's a scientifically accurate way of actually presenting the data. So you do a pass to the whole data, you get a scientifically accurate output, and even if you zoomed in, we're doing that with a full pass each time. So those extra optimizations do exist, but we're not actually using them, and we've not found much need for them yet. So, yeah.
Okay. Can you add new points updating existing charts?
Yes, you can. Yes, you can. You probably have to do a little bit more work. You need to probably use HoloViews and something called dynamic map, whereby you could generate the data rasterized plot with Datashader for each zoom level. So you basically get some information about the bounds, the viewport that you're looking at. You pass the Datashader, you render it, and you have a chance at that point to get that data from anywhere. You could get it from a database. It could be updating. There could be more points appearing. It could be live. All of that's possible, yeah. Not possible, I don't think. Maybe with the Streams API, I'd have to check, but I don't think offhand that it's possible with the hvPlot API, but it's definitely possible with the HoloViews tools as a whole.
Is it possible to define other aggregations for each pixel or groups of pixels kernel?
Excellent question, and the answer is yes. We have the count is one of them, which you just saw, where you have the count of the pixels. But we have other statistics we can do. You can do the max, for example. You can do, I think, a mean. Right? You can take the mean of all the samples in that pixel. There are different aggregations we can do. Yeah, we have a selection of them. You can check them out on datashader.org. Yeah.
Can you export the images for use in other programs, web-based mapping frameworks?
Oh, OK. You mean like tile servers, maybe? I don't know. So you can, of course, export to PNGs, and PIL comes with Datashader for sort of simple image output. To do a tile server, we've had projects based on this before. It's possible. I don't know what the status is in terms of being it public and being usable, but we have worked or had projects where we wanted to use Datashader to have a tile server where you could put it online, and then just like Google Earth, you could zoom into anything you want with a web, just with a URL, yeah.
Does multi-point selection also work with the most powerful overlay solution?
Okay, another good question. So when you have overlays, that's normally when you'd have categorical, like when you had the multiple ethnicities in New York City or the different types of shipping vessel, we want different colors. That's an overlay. Right now, I think if you use Datashader itself, you use the Datashader operation, which gives you the RGB, which means that you have all that information in Datashader. But to get it out, I think at the HoloViews level right now, it's separate. It's a separate pass of Datashader for each one of those things, especially if you want to use the inspection and tools I've been talking about. So, but that's a good question. It's something that we have in mind and we're thinking about.
Okay, next question is, why did it require a new API to add inspection support?
Just time, really it's just development time. We know what to do, we know how to do it. It's an open source project, so our main jobs aren't always just working on open source. We work with clients and other things. So we work on open source when we can, and when we have the time, we'll add this. We know exactly what to do. We just haven't got round to it. That's all. Yeah.
Okay, perfect, awesome.
Okay.
Thank you very much.